Hello everyone, MK is here. This class I'll be discussing electric field with you. Nothing to teach you. You are in class 12, you are grown up, you can manage everything yourself. But this session I'll discuss the concept of electric field with you. Before you start anything, just what is the learning from last two videos I have shared with you. The first video I made to show you that a fly is trapped in spider's net. It cannot come out. Something is opposing to come out from the spider's net. And second video, I have shown you the action of charged particles. They are being attracted, they are being repelled. When I discuss electric field, we have to remember the concept of Coulomb's law in mind. In Coulomb's law, two charged particles, you have seen that either they attract or they repel. If they are dissimilar charges, they attract, and if they are similar charges, they repel. This force of interaction between two charged particles we can think as two-step process. What is the first step? First, a charged particle will create something in its surrounding. That will refer as electric field. And then the electric field created by one charge will interact with the other charge. I am considering the existence of two charges in the beginning. So, when two charges are there, a charge will create something in its surrounding that will be referred as electric field. Then the field exerts force of attraction or repulsion on the other charge. It may be many charges are there, but we will be thinking between two charges first. In this session, I'll be covering the following topic, that the concept of electric field. And when we discuss concept of electric field, concept of source charge and test charge is required. Then we'll define electric field strength. Electric field strength due to a point charge. Electric field strength due to a continuous distribution of charge. We have got time to discuss this one today. So, electric field strength due to point charge we will discuss. And then we'll discuss superposition principle. When many charges are there, how electric field we have to determine due to many charges, that also we are going to learn. I'll be discussing some problems also with you, and then if possible we'll discuss the graphs of electric field due to two positive charges staying side by side, or two negative charges, or one positive and one negative charge. So without wasting time, let us start. Electric field, going to unveiling the invisible forces. What about gravitational field? Have you learned gravitational field before? Yes, you did it in class 11. One huge chapter. Many things you have learned over there. But electric field is not like gravitational field. I am not going for comparison this class. So electric field is the result of interaction of two charges, where one charge will be considered as the test charge and the other one is source charge. What is the rule of test charge here? Source charge is understood. Okay, let me take these two charges here. One is charge Q and the other one is Q0. They are kept in air at some distance of separation. The distance of separation between two charges is equal to E. Now this charge Q and Q0, they will interact. Either they will attract or they will repel. And I told you earlier that force of interaction will be seen as two-step process. What is the step one? If I consider the action of this charge on this charge, let us assume that in the beginning this is superior and this is inferior. This is like the spider which creates nets in its surrounding, and this Q0 is the fly which cannot ignore the presence of the spider, and spider attached the fly in its net. So here this source charge, which may be a point charge, this source charge may be a point charge. It may be a continuous distribution of charge. Or it may be a group of charges. Okay? And this Q0 is this we have referred as source charge. Source charge will create something in its surrounding which will be referring as electric field. And this test charge will realize the presence of the source charge. Source charge huge in compared to test charge. This test charge is so small that it also will create something in its surrounding. Don't say that it doesn't have the ability to create something which we have referred as electric field, which is created by this charge Q. It will be created by this test charge also. But test charge is so small that it cannot affect the electric field created by the source charge. So this source charge Q creates electric field. And this field will attract or repel the test charge. Test charge is vanishingly small. You can say that test charge is so small that in the language of limit, it is tending to 0. So this test charge is tending to 0. It has no influence on the source charge. Source charge will create field. That field will interact with the test charge. This is the concept here. Now the question is, what is electric field then? How to define electric field? This electric field is the region of space. The spider creating net in its surrounding. How far it can create, it depends on the spider only. So here also this Q, actually little bit dissimilarity is there. Spider has limitation, but this charge will create the field which is extending up to infinity. Whenever this charge enters that field, it will experience force due to the charge Q. But one thing I would like to say, like if you remember that Coulomb's law in your mind, that force in vacuum equal to Q into Q0 by R square, then a vacuum, this will vanish when R tending to infinity. So electric field will exist up to a long distance, but the field will be experienced up to a over a limited region only. Okay. So by definition, electric field is the region of space in the surrounding of this point charge where its influence is felt by the test charge. This is electric field. So hope all of you have understood what is electric field. Now we are going to learn what is field strength. How much this test charge going to experience force when it enters the field created by this charge. It is quite obvious when a charge Q is there. This we have learned in Coulomb's law only. This charge will exert more force if this one close. If this one far away, then force going to be reduced. So keeping this in our mind, we are going to define EFS or electric field strength. What is that? By remembering the fact that if it is close to the source charge, it will experience more force. If it is far away, it will experience less force. So electric field strength is the force experienced by this test charge per unit charge of it. So EFS is what? Force experienced by the test charge per unit charge of it. Understand? So per unit charge, how much force it is going to experience, that is called electric field strength. Now, to find that value of electric field strength, we first calculate the Coulombic force. The Coulomb's force here is given by F equal to the charge B situated at a distance R. It is going to be Q into Q0 by 4 pi E0 R square. By definition, EFS, which we denote by the letter E, is going to be F by Q0. Okay? And this E is a vector quantity. This has direction same as that of F. At this condition on Q0 will be it is tending to 0. So electric field is a vector quantity. It is directed along the Coulombic force of attraction or repulsion only. So their electric field, by assuming Q0 positive charge, will be radially outward. And if Q0 is negative, then actually one thing you have to make clear, that this test charge Q0 is always positive. This is always positive. So when you consider direction of electric field, sign of Q is important. If Q is positive, then this test charge will experience force towards Q. So field is directed inward. So for Q positive, the field at a point E is directed radially outward. If minus Q is there, electric field at a point will be directed inward. E will be directed inward due to minus Q charge. So what is happening actually? Due to this charge Q, you take the test charge any point taking away from it, it goes on experiencing force this manner. And here it goes on experiencing due to negative charge in this manner. Actually, this is the concept of electric field line. Electric field lines will be directed this manner. I will be explaining electric field line in separate session, but the concept of electric field line arises from here. What is that? That is the direction in which a vanishingly small test charge, or you can say even 1 coulomb charge. No, 1 coulomb may be very large in compared to it. It is the direction in which a test charge will experience force. Due to plus Q, the field is radially electric field. Direction of electric field is radially outward. And this electric field is radially inward. Okay. So in this example, we have taken a charge which is point charge. Due to this point charge, we are going to find the strength of electric field at a point. How to find the strength of electric field at a point due to point charge, that I am going to discuss now. So two important things you have learned now. Concept of electric field, which is nothing but region of space in the surrounding of this charge, and then electric field strength. It is a force experienced by a vanishingly small test charge per unit charge of it. So if we keep a charge Q here, Q0 here, this test charge will experience force. How much is the force that you know? F is equal to, I am assuming this one plus Q charge. So field will be directed radially outward, I told you earlier. So that F is going to be K multiplied by Q0 by R square. Okay. But if it is radially outward, we should put unit vector which is directed radially outward. This is F. Then E is what? By definition, it is F by Q0. What's the condition? The condition is you can put the concept of limit here, that is limit Q0 tending to 0, F by Q0. F by Q0 is what from this calculation? If you just divide both sides by Q0, F by Q0 is going to be KQ by R square into R cap. Okay? And this field is radially outward. Same, E, if you write E, that E is radially outward. KQ by R square, R cap. But if it was negative charge, what will be the direction of electric field strength? If it is negative charge, if charge is minus Q over there, then at this point, Q0 will experience inward force and E going to be KQ by R square, that R cap we take minus. It is directed inward. That's why. I hope all of you have understood the expression for electric field. If you take magnitude, then E is nothing but mod E, which is given by KQ by R square R cap mod. Alright? So E equal to KQ by R square. Direction if you keep in your mind, then the magnitude will be given by this tradition KQ by R square. Now a very important question arises here. In what direction a charge will experience force when it enters the electric field? Suppose a charge is there, which is the source charge. This source charge Q. Due to this, it is positive charge, electric field radially outward, that I have explained. Now a question is there, how much force does this, not this one, how much force another charge Q dash will experience when it enters the electric field of this source charge? Try to understand the problem. This source charge is there. This source charge creates electric field in its surrounding. The strength of electric field at a point is E. What is the force experienced by the charge Q dash, where strength of electric field is E. Magnitude, direction, both are shown here. You just remember the definition. It is force experienced by vanishingly small test charge per unit charge of it. So if we keep, by definition, strength of electric field is the force experienced by unit positive charge. So you can go by unitary method. Unit positive charge will experience a force E. If unit charge is there, it will experience force E. If the charge Q dash is there, it will experience Q dash into E. Okay, this you should keep in your mind. So a charge, when it enters the electric field created by a source charge, will experience a force which is given by the magnitude of charge multiplied by E. Let us find one application of it. Question is this: calculate the electric field intensity which would be just sufficient to balance the weight of a particle of charge minus 10 mu c and mass 10 mg. So minus 10 mu c. If we go back to the concept of that direction of electric field, that plus q creates electric field in its surrounding. A positive charge will experience force radially outward, so electric field directed that way. And a negative charge is there that will experience force towards the charge. Okay. So, if there is a charge minus 10 mu c, a positive charge will experience force along field, negative charge will experience force opposite to the field. So, if there is a charge plus q, it will experience force along field. If there is a charge negative, it will experience force opposite to the direction of electric field. We are going to use this concept. So, this minus 10 mu c, whose weight is 10 milligram, that is 10 into 10 to the power minus 6 kilogram, that will experience force opposite to the direction of electric field. Here force of gravity is there, that is acting downward, mg, and electric force must be in a direction opposite to it. So the most important thing is that in what direction you have created electric field. It's a negative charge, minus 10 mu c, minus 10 into 10 to the power minus 6 coulomb. It has to experience force, if this is q, it has to experience force QE upward direction, because weight mg acting vertically downward direction. These two will balance. Am I clear? If this is a negative charge, it will experience force in a direction opposite to electric field. So the question is, what direction electric field is created? It is created vertically downward. Electric field directed downward. So this charge minus 10 mu c will experience upward force to balance the weight, its own weight. So for equilibrium, QE must be equal to mg. Therefore, E equal to mg by q. You just substitute the value. Mg means 10 into 10 to the power minus 6 into 10 by 10 into 10 to the power minus 6. So this is 10 Newton per coulomb. Why Newton per coulomb? Because electric field E equal to F by Q0. F is in Newton and this Q0 is expressed in terms of coulomb. So unit of E is going to be Newton per coulomb. Other units we will learn in the following chapters. Right now, the present chapter, you will write the unit of electric field as Newton per coulomb only. So before we enter the next part of our discussion today's class, we will remember the concept of electric field and electric field strength once more. Field is the region of space, electric field strength is the magnitude of force experienced by vanishingly small test charge per unit charge of field. Sometimes for our calculation, we will take that vanishingly small test charge as 1 coulomb. But definition wise, it will be wrong. When you are going for numerical calculation, that you can manage by placing 1 coulomb charge, which is going to play the role of unit charge, okay, or vanishingly small test charge per unit charge of field. But 1 coulomb charge may be larger than the source charge. 1 coulomb charge is huge. So numerical calculation can be done easily when you are calculating electric field strength by keeping that point 1 coulomb charge. But concept is actually, it is always force experienced by vanishingly small test charge per unit charge of field. And these three important points we will always remember when dealing with electric field. Directionality. What is that? Electric fields are vector quantities, meaning they have both magnitude direction. Direction of electric field at any point is the direction in which positive test charge would move if placed at that point. But in the previous example, we have seen the action of a negative charge. That negative charge, what it will do? Negative charge also exists if positive charge is there. The negative charge will experience force opposite to the electric field. Like Coulomb's law, principle of superposition is valid here. I am going to discuss that. Inverse square law also valid, that we have seen. Electric field strength magnitude is kq by r square. Inverse square law is valid over there. Okay. Now superposition principle. Like Coulomb's law, when you consider electric field at a point P due to many charges are there. At least two. Many means at least two. Then how to find electric field at P due to these two charges? So again, superposition principle we are going to state. Electric field at this point is the vector sum of field created by the charge Q2 and the field created by the charge Q1, their vector sum. So if Q2 creates a field E2, Q1 creates a field E1, then electric field is the resultant of E1 and E2. This is ER. Alright. So ER is actually the resultant of E1 and E2. If three charges are there, just to add another one. Q3 is there. Then you find electric field strength at P by ignoring the presence of these two. Whenever you are finding electric field at the point P due to one charge, you don't consider the existence of other charges. So when you find electric field at P due to Q1, it is E1 by ignoring the presence of these two over there. E1. Due to this, E2. Due to this, it will be E3. So E3 directed this way. This time resultant will change. Resultant of E1, E2, instead of considering these two things separately, we will find resultant of E1, E2 and E3. E resultant is going to be equal to E1 vector plus E2 vector plus E3 vector. Okay? So this is superposition principle. If many charges are there, then electric field at a point due to a charge is not affected by the presence of other charges in their surrounding. Electric field, net electric field at a point is the vector sum of all the fields exist over there due to each individual charge. This is the strength of electric field. Now let us solve one problem where superposition principle is in use. 2 point charges 16 mu c and minus 9 mu c are placed 8 centimeters apart in air. This is 16 mu c. Line segment joining these two I have taken here minus 9 mu c. Determine the position of a point at which resultant electric field is 0. So let me discuss the principle here. We have to keep vanishing these small test charge so that it experiences no force. But can that point be here? This point, I mean on the line segment joining two charges. If we keep vanishing this small test charge Q0 over there, does it experience 0 force due to plus 16 or minus 16? No, never. We'll be using formula, but I'm just discussing the situation with you. Charge can never be there. Can this charge be here? Just the line segment I mean outside the line segment joining these two? Possible, because Q0, or by now we will not keep Q0, we will keep unit charge over there. We will remember unit charge exists over there. Due to -9 mu C, field will be directed this one towards negative charge, you know, and due to positive charge it is outwards. So there is a chance of getting a point outside. Is it possible to get a point here? Here, plus 16 will repel the unit positive charge. You either keep mentally Q0 over there, vanishing this small, or unit positive charge. I am not telling 1 coulomb charge. 1 coulomb is really very large. Just a unit positive charge. Maybe 1 microcoulomb, maybe whatever. It is unit charge. It will experience repelling force here, and -9 coulomb will attract it. So there may be position of the third, that unit charge here, so that electric field can be 0 at the point D also. So it is not possible to get null point. Null point means where net electric field 0 on the line segment joining these two. It is outside the line segment joining these two. So let us work accordingly. Let us assume that the charge is at a distance x from 16 mu C, here on the right side. Okay, taking this direction, positive direction. X from 16. So from 9, how much distance? Or you take this total distance, you have taken x. So this is going to be equal to what? This distance. The distance between these two is taken 8 centimeters. So if you have taken this one, this total distance x, this part going to be x minus 8. So electric field at C due to -9 coulomb will be what? Kq by x square. 9 into 10 to the power -6 you take by the distance we are taking in terms of centimeter. No problem. We are just keeping unit accordingly. So it is Kq by, from this 9, the distance is x minus 8 whole square. In what direction? This 1 coulomb will experience force towards left. So this electric field EC is directed towards left. This is towards left. And electric field at C, it was due to charge at B. Now electric field at C due to charge at A will be what? K into 16 10 to the power -6 by, from 16 distance is how much? That we have taken x square. Okay. In what direction? Towards right. It is towards right. So as told earlier, the net electric field will be 0 here. We have assumed. So put ECB equal to, they are equal and opposite, then only field will be 0. So you compare these two fields. ECB will be what? K into 9 into 10 to the power -6 by x minus 8 whole square. Centimeter doesn't matter, get cancelled from two sides. Answer will also be in terms of centimeters. Alright, and this is K into 16 10 to the power -6 by x square. These two are getting cancelled. 10 to the power -6 part also. So 9x square equal to 16x minus 8 whole square. So plus minus 3x, you take square root, equal to 4 into x minus 8. Now you take plus sign once. For plus sign here it will be 4x minus 32. So x going to be equal to 32. 32, this will be in centimeter. I told you earlier, this is in centimeter. For minus sign, what will happen? For minus sign, what will happen? It is minus 3x equal to 4x minus 32. If you are taking minus sign here. So minus 7x is minus 32. So x will be 32 by 7. Okay. So x you are getting, once you are getting, taking plus sign, you are getting x is equal to 32, taking minus sign, you are getting 32 by 7. Now a question arises, what are those two positions? So this one, this distance, x 32, it will exceed 8. So we will be taking this 32, the value of x 32 here. This part is 32 here. And next one, it doesn't exceed, but it exists. X is 32 by 8, 32 by 7 we got. This exists. Then what do you get? This x, it is smaller than the line segment joining these two. So that distance will be here. This distance 32 by 7 centimeter. So your answer will be either 32 centimeter away from the charge minus 9 mu c, or at a distance 32 by 7 away from 16 mu c, I mean left side of it. This you have to state clearly. Now the second question arises that 2 mu c and 8 mu c, they are placed 12 centimeters apart. Line segment we have taken 12 centimeter. This one is 2 mu c and this one 8 mu c. They are placed 12 centimeter apart in here. Determine the position of the point at which the resultant electric field is 0. Now, before we solve the problem, we have to analyze. Can the field be 0 at a point on the line segment joining these two charges? Charges are at A and B. Yes, it is possible. That point be here. Point be here. Then this 2 mu c charge will repel the unit charge placed here. This one also will repel the unit charge placed here, but towards left. This 2 mu c will repel towards right. 8 mu c will repel towards left. These two, their resultant will be equal to 0 on the line segment joining these two. I mean 2 mu c and 8 mu c. Can it lie here? Can the point C lies here? Just think analytically. The point be D, outside the line segment joining these two. 2 mu c will repel the unit positive charge outward. 8 mu c will repel the unit positive charge really outward. So, strength of electric field at D can never be equal to 0. So, the point where electric field strength EFS equal to 0 must be on the line segment AB. It can never be outside of it. So the distance for electric field strength going to be 0, be x. So this part going to be what? BC part, this is going to be 12 minus x. So you just find electric field at C due to charge at E. It is K into 2 into 10 to the power minus 6 divided by x square. I am keeping unit accordingly. No problem. This time centimeter square I have taken denominator because here also I am going to take. C at B, I mean electric field at C due to charge at B will be K into 8 into 10 to the power minus 6 by 12 minus x whole square. Just compare these two because net field will be 0. So comparing we get ECA equal to ECB. So this implies 2k 10 to the power minus 6 by x square, 8k 10 to the power minus 6 by 12 minus x square. So these two get cancelled, kk also get cancelled, 2, 8, 4, therefore 12 minus x whole square is 4x square. Just take square root like previous sum. 12 minus x will be plus minus 2x. So now take x positive first and then x negative. If you take positive sign, by taking plus sign there, 12 minus x equal to 2x. So 12 equal to 3x, x equal to 4. So before we do anything else, this observation is very important. X4 means field will be 0 near the smaller charge. This observation you must make. X4 and total length is 12. So 12 minus x is 8. So it is away from 8 microcoulomb, close to 2 microcoulomb. These small observations will help you later, at least when you are plotting the graph of electric field versus distance. So x equal to 4. So electric field strength will be 0 at a point which is close to the point A. Clear? Now, if we take minus sign, 12 minus x equal to minus 2x, this implies x minus 12. That is not possible. Because minus 12, then it will be outside the line segment. Or if you take x equal to minus 12, it will lie here. That is not possible. It should be on the line segment joining two charges always. Clear? This one is an interesting problem where three charges each equal to q are placed at the three corners of a square of side A. Here problem is to find magnitude of electric field at the fourth corner. So this is the square. I'm just drawing line segment joining any two vertices here, that A, B, C, D. You have kept 3 point charges at the point B, C and D. And you want to find electric field at the point A. How to find? This one is a good application of superposition principle. Electric field exists at the point A due to this charge Q. That electric field we are taking EAB. Okay? Electric field exists at A due to charge at D. That we are taking EAD. Okay? Electric field exists at A due to charge at C. It will be directed this way. Okay? EAC. Before we go further calculation, we must check the value of EAB. EAB is how much? EAB is how much? This side length is A. It is mod we are writing because direction already shown. It is KQ by A square. And EAD has the same magnitude. KQ by A square. But EAC, it has different value. This is equal to KQ by root 2A whole square. We have to find vector sum of these three vectors at the point A. Before we find vector sum, we make one observation that magnitude of these two vectors same. And EAC, it acts along the bisector of the angle between these two. So don't you think that the resultant of EAB and EAD is along EAC? It's a very simple observation. So EAC and resultant of these two, their sum will give you the resultant, and the resultant electric field will be directed along EAC only. So let us write the resultant of EAB and EAD first. That resultant we are taking E dashed. So E dashed going to be what? Angle is 90 degree. E dashed going to be under root EAB square, EAD square, angle 90, so cos 90 is 0. I am not writing that. EAB, EAD has the same magnitude as shown there. You must have seen they are the same magnitude, KQ by A square. So this is twice EAB square. This is root 2 multiplied by EAB. EAB is KQ by A square. So it is root 2 into KQ by A square. So resultant electric field at A, EA magnitude will be E dashed its magnitude plus, because they are acting in the same direction, they will be added. E dashed is what? Root 2 into, we found it, KQ by A square. This plus EAC, that is KQ by 2A square. You add these two, KQ by A square common, root 2 plus 1 by 2 is the resultant electric field at the point E. Okay. Another very interesting problem. Equal point charges are placed at the corners of an equilateral triangle, a square, regular pentagon, regular hexagon of side A. All of them have side A. Calculate electric field intensity at the center. It's a very interesting question. But we can answer just by keeping a simple concept in mind, which you might have done in class 11. You must have done. So let us do it for equilateral triangle. There will be an equilateral triangle, side length equal to A. We want to find the strength of electric field at the center. How to? See, electric field, here you have kept Q charge, here Q and Q. These three charges will create electric field here. It will be directed this way. Due to charge at A, this point we are taking O. It is EOA. Electric field at O due to this charge Q placed here. Electric field at O due to this charge B placed here will be EOB, directed this manner, and electric field at C due to charge, electric field at O due to charge at C will be directed this way, EOC. Alright? If three vectors act at a point where the angle in the surrounding of the point divided in three equal parts, their resultant has to be 0. I will be using this concept here. So EOA, their magnitude same. EOA magnitude is what? The value of OA, OB and OC, they are equal. What is its value? It is 2/3 of height of triangle. Root 3 by 2A. So this is A by root 3. All three are equal distances. This equal to this, equal to this. They are equal. So EOA, EOB and EOC, their magnitude same. Okay. That magnitude is given by KQ by A square. A means A by root 3 whole square. As they divide the angle in the surrounding of the point in three equal parts. What are those? It is 2 pi by 3. It is 2 pi by 3. It is 2 pi by 3. Their resultant has to be equal to 0. So E at O must be equal to 0. Now, if you don't like this method, then I have another suggestion for you. which I am not going to discuss with you now, but I'll just give you some clue. You just take the x-axis this manner, okay, y-axis this manner. Then by taking component along x and y axis also you can prove. It's very interesting to prove there also. EOB's component along x axis, EOC's component along negative x axis get cancelled. Along positive y axis, what will you get? That EOB and EOC's component that will be cancelled by EOA. This way also you can prove that electric field at O equal to 0. But I'll tell you to remember this concept. This is a very interesting concept where if 3 or more forces divide the angle in the surrounding of a point in equal number of parts, see, even for a square, if you want to find electric field at the center of a square, you just look at the diagram. Now, 4 charges are there, A, B, C, D. Electric field will be directed this manner. Due to B, electric field will be directed this manner. Due to C, electric field will be directed this manner. Due to D, electric field will be directed this manner. Okay. Now these 4 forces will divide the angle in the surrounding of the point O in 4 equal parts. What are those 4 parts? 2 pi by 4, that is equal to pi by 2. So electric field has to be 0 over there. Even for regular pentagon you practice at home, even for regular hexagon. Hexagon also it is going to happen the same manner. I am showing you just. Although it looks irregular, but assume regular hexagon is there. Q, 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 Q. So what is the strength of electric field at the center? Again the same manner. Electric field due to plus Q charge will be directed this way, due to this Q will be directed. Another reason is there, they get cancelled simply. This and this also get cancelled. This and this also get cancelled. So they cancel in pair, resultant electric field will be 0. For hexagon, easy to understand. For square also you can do the same manner. But if question arises, if they are kept at the vertices of n-sided regular polygon, then what is the logic? Then you have to state this manner. At the center, those electric fields making an angle for n-sided polygon which is equal to 2 pi by n for each. So resultant field will be 0 over there. Alright.